5 times 5 is?
25.
Yeah. Hey folks, welcome. Yes, that's a good welcome for everybody. We are so glad you've tuned in this afternoon. I'm Ernie Roberts. I'm your host for the show is MATHLINE, in case you haven't figured it out already. And I know a lot of you tune in every day, and we love it and we appreciate you. Those of you may be tuning in for the first time, yes, well, what do you do on this show called MATHLINE? We work math problems. Yes, that's one of the big things. But we try to give help to you live on the air. So there's a number that we have you call, 844-686-2378. That's all you've got to do. Put that in your cell phone. Put it on speed dial. Give us a call. We'll work the problems out. Yes, you got it live on the air. Not tomorrow, but today, if you get the call in on time, all right? So you want to go ahead and get those calls moving. We have operators from the Bearden High School Key Club once again. They are been wonderful to stay with us all week. There we have Jesse and there is Emily. And thank you, and let's get them busy. We want to have phones ringing off the wall today, all right? From start to finish, wall to wall. Why not? Why not? Because we need you to hear that. And because why? You make the show rock when it does that. So let's get the show rocking and let's head to our problem of the day. Problem of the day, looking for two things today, it looks like. Find the perimeter and area of a rectangle with a diagonal of 20 inches and a width of 16 inches. Salute. A lot of information in there. A lot of things we're looking for, I guess, and kind of wondering if there's something missing. So we look at the perimeter. We're looking for area. We're looking to have a diagonal, and we've got a width. Perhaps that's a length. It doesn't really matter. So one of our dimensions is 16. We're going to go out on a limb and see what happens. Let's take a look at a picture of that, all right? First of all, again, we're looking for two things, perimeter and area. And my friends, what you need to have for perimeter or area, you got to know the length, you got to know the width of the rectangle. You don't have the choice to be left in the dark. So let's bring a diagonal in. Now, take a look at this picture. Take a look down there. You have two possibilities here. You could, well, yes, you could. You could go this diagonal, or maybe you should go this diagonal. Does it matter? They're the same length. So let's just go ahead from, it looks like the upper left, to the lower right. Get my thoughts ahead of me a little bit there. And let's draw in a diagonal, which makes things a little bit easier to look at. Really make things easier if it'll mark. There we go. I always love pens, you know. We've got a right angle heading in there. How do we know it's a right angle? Because it's a rectangle. And we got other right angles here in case you were wanting to play out of this triangle, or if you wanted to form a triangle going this way, and we got one going here. So all of the above, those are our situation there. Now, information, what do we know? Well, we know we have 20 inches going right here on the diagonal. That's pretty good. And we have a width of 16. Now, I'm going to go with a 16 down here, all right? Because I already know the answer. No, just kidding. I want this to be obviously missing, and it's going to be actually a little bit smaller than 16 when we run this thing through. So just to give you a heads up, just a little intuition on that. Again, looking where we are here, we have a right triangle. What do? We need to figure out what this value over here is, and we're going to play it off the good old buddy and friend of ours, Pythagorean theorem. So, which says, if you remember, a squared plus b squared equals c squared. That's for a right triangle. Now, what are a and b representing? That infamous formula. Those are your two legs. C is your hypotenuse, which is the longest piece of the puzzle here. So what do we need to do? We need to do some substituting. And it's really immaterial where you substitute, except 20 has got to go in for C. So in other words, what I mean is a squared, I want to leave it open. I could have put 16 in for A. It really doesn't matter. And we'll put in 16 for B. We will square it. And we'll put in the 20 for our C value and square it. That is the most important piece. Remember, the hypotenuse is the longest segment, and it's also opposite the right angle. So there you go in terms of your right triangle. And in this case, it's also our diagonal. Now, let's do some squaring. How about it? A squared plus, what is 16 squared? Y'all got the tip of your tongues? Maybe I don't. How about it? 256. That's what I remember it being. And let's pick up 20 squared. That one's easy to do. That'll give us 400. Now, as we look here, the whole gang here, what are we trying to do? Goodness sakes. We're trying to get A by itself. So let's subtract 256 from both sides, and let's see if I can stay on the page. I'm going to leave this with A squared equaling, it looks like 144. we're going to kick that up here, all right, so we can continue to play a little bit. So we've got a squared equaling 144. I need to know what a is. A squared is nice, but I'm worrying about this little guy over here. So in this case, it's really x, all right, xa, however you want to call it. So let's see what's going to go on. We're going to take the square root of both sides, and that's going to give us a equaling 12, or x equals 12, for those of you who used x squared plus 16 squared, okay? And you know what happens? That's what we're looking for. That's important. And does it work? Well, 12 squared is 144. 16 squared is 256. Add those together, we do get 400, so life is good. Now, the problem is asking us to take that solution. You say, oh, you mean we're not done? No, 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 folks, we are not done yet. So we're going to take that solution and we're going to find our perimeter, which is pretty easy. So we got 12, we got 16, we got 12, and we got 16. We'll add all four sides together. By the way, they are going to stay in inch form here, so it looks like, how about it? Notice I got 24 and 32. What are we going here? It looks like 28, 28. We can do a lot of different ways to add these up. It looks like the perimeter is going to give us 56 inches, okay? Not square inches, that's area, all right? Now in the area, we're going to take our little 12 times 16, because what do you know area is? Oh yeah, area is what? Length times width. And we're going to take 19, no, we're going to take 12 times 16. Let's hit the calculator on that one and see what we get. I'm getting 192. I was thinking that 19 in advance here. All right. So it's 192 inches, and those folks are, let's just write them square inches. And there's your value there. So perimeter, just inches. Area, square inches. Sometimes we like to put IN with a little 2 there. I was about to put the symbol back up there, but hey. Anyway, you got the idea. That's your problem of the day. Pretty straightforward. Obviously, what you had to have were your 2 dimensions. Once you got those, everything was fine. As long as you press the right buttons on the calculator, right? Hey, that's our problem of the day. Now, let's get those phones ringing. We've got folks from Bearden High Key Club here to take care of us. I understand someone else has already got themselves on the waiting list here. So let us talk here. Welcome to Mathline this afternoon. Who am I talking with?
Playing with Lucy.
How are you doing today?
Good.
Good. And where are you calling from?
Knoxville.
Knoxville. Okay, our viewers always like to know kind of where people are calling in from. So we got a Knoxville, Tennessee person here. And what can I do for you this afternoon? What's our problem?
What is the 1/2 times 2/3?
2/3?
Uh-huh.
Okay. And what's the other one? So I think you said we're going to figure out what's the most, right? Or which one's greatest?
1/2 times 2/3.
Okay, got that. What else do we need? Got another one?
Use a normal line.
Okay. All right. I think you said which one is the most. Is that what you said?
Nope.
Oh, okay. In that case, I stand correct. You just want to figure out what we got here, right? Let's see what happens here. Yes, okay.
Use the normal line.
Oh, do it on a number line.
Also.
Okay, all right. So we're going to look at being on a number line. All right. So here's kind of how we're going to work on this one. Good question.
Okay, 0, 1, and 2 on the number line.
All right. You got 0, 1, and 2 right on the number line.
Uh-huh.
Okay. Now here's what I'm going to do with the number line here. You're taking what, 1/2 of 2/3, right?
Mm-hmm.
So are we trying to multiply them, or are we trying to figure out where they are on the number line?
Okay, multiply.
We're going to multiply. Okay. All right. And then we're going to work it off the number line also. All right. So here's what I'm going to do. I'm going to go here and I'm going to figure out where 2/3 is. Now you know where 1/3 is about right here.
Yes.
And here's 2/3. Okay.
Mm-hmm.
We good? And I'm going to mark that 2/3 right there. And I want to find the point that is halfway between it. Now look what goes on here. Right there it is, isn't it?
Mm-hmm.
So what this amounts to is I can break this thing into basically, it's in halves, okay? I'm taking a half.
Mm-hmm.
So where am I back here? This is going to be what? 1/3. So each time I basically have broken this thing up into what? The 2/3 into halves. That's what I'm taking, 1/2 of 2/3. And guess what? There is your value right there. Does that make sense to you?
Yes.
Now, for those of you who are purists out there and go like, whoa, I've not done number line multiplication before. Well, that's just a visual way to look at this. Let's say we're going back to the way a lot of us remember doing it. Oh, we have 2's that cancel out, or we just multiply these together. Well, you get 2/6. And look what happens. We still get what? 1/3. That's just another way to envision it, all right? Now, can we do one more problem? Can we do one more?
Yes.
All right, let's do one more. Let's say I have a number that's bigger than 1, all right? And let's say I'm going to take 1/2. Oh, let's say, how about, 1 2/3. How's that? Okay. So we're going to, let's just regroup the number here. Let me put another number line down here for us. And we're just going to keep it, again, I'm going to keep it between 0, since these are positives. And we'll go out here like we did with 1 and 2, right? Because this way you get 2 different looks of it, okay? Now, what I'm going to do is I'm going to break this thing where we are at 1 2/3, which is about right there. And I'm going to break that thing into halves, okay? This one's not as easy, quite so easy. It was nice when we had an even number, wasn't it? So it looks like we're going to end up with basically trying to break this distance between 5 in here. Woo-hoo. Not 5 of them, but it looks like we have 5/3 going here, and we're going to try to break that into thirds. That's kind of hard, isn't it? So we're going to estimate somewhere, we know it's between 0 and 1, right? And I'm going to just look and see what it might take for us to see, what is this thing? It looks like it is 5/3, isn't it?
Yes.
So let's look at it as 5/3, all right? Because that's what we would do, wouldn't it? It helps us a lot to know that it's 5/3. So really what I'm kind of looking for is where's 2.5, isn't it? 2.5 over 3, which doesn't make much sense. Doesn't make much sense to us. So what we're looking at is trying to figure out, now how can I break this thing down into 2 equal parts? And what it's going to be is going to be 5/6 plus 5/6. Because I can make this into how much? 10/6. And now I've got even numbers which are easy to work with, right? I can break those down to 5 and 5. So back here somewhere, I am looking for that point that's going to be about 5/6, and that's going to give me a half here of 5/6, and that's going to give me a half here of 5/6, and hopefully that's going to give me 1 2/3. Now, are you ready to see let's see if it works the old-fashioned way?
Yes.
I have 1/2. Remember, I made that into 5/3. You know how I did that? 1 times 3 plus 2, and I had 5/3. See what I did? 1 times 3 gives you 3, right? Add the 2, get 5 over, and that gives me 5 on the top, 6 there. This is a nice creative way of showing how you're multiplying with the number line. Is that good? Does that help you? And again, it's kind of hard to envision 5/3, so that's why I changed. Let's go to 10/6. I can split that up in halves. And let's say if I wanted to split it up in thirds, I would have trouble with that too. So again, you kind of have to work your numbers to where they're going to work nicely for you. This one that you gave me, I liked. I like that, Sammy. You got it going good there, 1/3 and 1/3, all right? Now, that made 2/3, but this one is still doable. Just took a little more effort, all right? Is that good for you?
Yes.
All right. Hey, thanks for calling in on us today here. And folks, it's that easy. Give us a call, 844-686-2378. And so, like I said, that's a physical way to look at the good old number line for multiplying fractions. And so a lot of you are going like, I just always learn numerator, denominator, and all that. Yeah, but we can do some other things, especially with those singular fractions there. And even you can make the mixed numbers into improper fractions, which is exactly what we do anyway, right, when we eventually multiply through. But right now, I digressed a little bit. Let's have some calls, all right? 844-686-2378. Bearden High School Key Club. Jesse and Emily are out there working today, and we want to make sure they have some fun, all right? And the fun is talking to you guys. And that number, again, 844-686-2378. And I understand, I think we have a MATHLINE waiting in the wings, right? Hey, MATHLINE? Oh, we got a caller waiting wings. Even better, even better. So welcome to MATHLINE this afternoon. Who am I talking with?
I'm River Shannon.
Is it River?
Yes.
River, all right. Glad to have you. Where are you calling from? What city or what county?
Knox County.
Knox County. Great to have another Knox County caller this afternoon, folks. Now, let me quickly, before we get started on our thing, that's the challenge to the rest of you counties out there. Give us some calls, all right? Knox County's been well represented today. Let's get some other counties from Tennessee and Kentucky, Western Virginia, and North Carolina. All you folks, give us some calls. And what kind of problem have you got for me today?
Word problem.
Okay, let's see what we've got. Throw it at me here.
So there is a painter that costs $50 per hour and $75 one-time fee. There is
Okay.
another painter that causes $65 per hour but no fee. How many hours would it take for both to have the same amount?
Okay, and you said it was $60 for the other person?
$65.
65, okay, $65 an hour. And you're trying to basically look where you're going to break even, right? How much time, because at a certain point, and this is a good practical application, because after a certain point, this guy up here is going to be more expensive, isn't he? Even though he's charging you $75 to begin with, actually he's probably going to be more expensive at the beginning, but sooner or later it looks like he may be the better deal, because the more you paint, the less he's charging an hour, right? Now this one starts off looking like it could be the better deal because they're not adding a fee. So what we're going to do, I'm going to let H be the number of hours. Does that sound good?
Yeah.
And the fee is it's just a one-time fee, right? We're not charging it every hour, otherwise this guy would already, they're never going to break even, are they? So I'm going to say 50 hours plus 75, that's what you're going to be paying the first guy, right?
Yes.
Does it make sense? We're going to do a little algebra here. On the other side of the coin, though, we've got this guy who is charging you what? 65 an hour. But he says, I start painting and I work away, all right? So the point where they break even, I'll give you a hint. Give you a little hint here. This one is going to be better until we get to a certain point. Does that make sense so far? Do you understand why I'm saying that?
Yes.
Because after a while, this $75 is going to be weighing on us. But sooner or later, this guy who's charging a little bit more up front, at a certain point, we're going to be needing to change painters, in other words. So let's see how this is going to work. We want to get H by itself, because that's what we're looking for, right? The number of hours. So let's subtract this 50H. You see where I'm going on the left?
Yes.
From both sides. And now I have a 75 left over here. It's just positive, so it's no big deal. And I have 65H. No, not 65H. What have I got now? 65 minus 50 is going to give me how much?
15.
15. There you go. So we forget that's not 615. Those of you just tuning in. It's 150. It's just 15H. Woo. Boy, it must be a Monday, but it isn't. It's Wednesday, isn't it? We're going to divide both sides here by 15, and that's where we're going to be able to figure things out. And let's see. We'll use the calculator for that real quick here. 75, you'll divide it by 15. I have a feeling are you in Algebra 1 at this point? Is that what you're getting this from? Or pre-algebra? Pre-algebra. So you're allowed to use some calculators after a certain point, I'm sure. So we've got 5 equaling to H, and that's the number of hours it takes. Now, let's just see how much it's going to cost after 5 hours, okay? We got 50 times 5 plus 75. On the other side, we've got 65 times 5, and we're going to see how much money they charge when they break even. This is going to be 250 plus 75. With me so far?
Yes.
That's going to give me, it looks like 325. We can punch that in a calculator if you need to. And I am going to do 65 times 5 on the calculator. And let's see where we end up. We end up at 325. So after the bill gets to 325, All right. River, this one's going to be the better, looks like the better deal. Because once you get to here, then this guy's going to start becoming more expensive. Before 5 hours, this is the one you want to go with. But this one is for after 5 hours, he's the best deal. This is less than 5 hours, he's the better deal. Make sense?
Yes.
Because that's going to be less than $325, and that's going to be more than $325. Well, no, I'm sorry. They're going to break even there. But when you put the numbers in there, that's what's going to happen. This one is going to be better deal in the long run after 5 hours is there. This one before 5 hours. Okay, less than. Got it? Sometimes I read too many things into those things. Does that help you a little bit? I hope with all my rambling there a little today.
Yes.
No good? All right. Thank you for checking in with us. Okay, that's easy work there. And we got one more caller waiting for us. This is the way I like it. I like this wall-to-wall calls, and we'll try to get through this one. If we get shut off at the end, hang on, and or give me a call back, or we'll check in. All right. Welcome to Mathline this afternoon. Who am I talking with?
Amy Felici.
It's Amy. Is that right?
Jamie.
Jamie. Am I right now?
No, Sammy.
Sammy.
Yes.
All right, Sammy, how are you today?
Good.
All right, what do you got for me? What's your next problem for me?
One moment, it's only.
You got it?
Still one moment, it's.
Okay. I think we're hunting it down. I know that feeling. Sometimes when I lose something too. You find it?
I got it.
You got it. All right. What's your problem for me there?
I got no problem. Sentence.
Okay.
Divide each whole number. No, divide whole into blank equal parts.
To length equals parts?
No.
No?
Divide each whole into blank equal parts.
Okay, so we're going to take a whole and we're going to divide it into different parts. Is that what you're saying?
Yes.
Okay, we're going to go from 0 to 1. Now we got it. Okay, now what kind of parts do you need? Because we're getting close on time here.
Okay, 6 and 2.
All right, so first of all, let's do 6 at one time, 6 in the first one, and then we'll do 2 in the second one?
Yes.
Okay, so what we're going to do here, Sam, we're going to take it from, we're going to divide this thing into 6 parts, right? So that means I'm going to say that means.
Wait, Oni.
Okay. I'm going to say this is 6 over 6 out here on the end, and this is 0 over 6 on this front end, okay?
Okay.
Now, I want to divide it in 6 pieces.
Okay, wait.
Okay.
2/5 times 6.
Okay, oh, you got a multiplication. I thought you were wanting to divide this, the whole piece into 6.
Okay. Yes, dividing also.
Okay.
Too.
All right, well, let's go ahead and do this one since I've got it set up here because we're about to run out of time, okay?
Okay.
And if we're going to run these things into 6, that means I've got 1, 2, 3, 4, 5. So we're going to say 1 over 6, 2 over 6, 3 over 6. How's that? 4 over 6, and then we got 5 over 6. All right? That's my fractions. But the thing is, I've got a couple of these that I can simplify. I can change them into what we call lower terms. So 2 over 6, that will reduce, I can divide 2 into both of those, right? All right, which is going to give me 1/3. I can divide 3 into both of these, which gives me what? 1/2. And then I can divide back into 2 here again, and that's going to give me 2/3. So again, that's 0. There's 1/6. 5/6 isn't going to change, is it? And there comes 1. So there would be how you would divide from 0 to 1 a whole length into 6 pieces, okay? You got 1, 2, 3, 4, 5, 6 pieces there, all right? Now, if you were going to do that in halves by 2, all I would need, I would take out these 2 right here. You see where I'm circling? And those 2 there, and I would just have a half, and then I have a whole. Okay? Would that make sense?
Yes.
Okay? All right, and they're about to cut me off there, Sammy, so I'll see if I need to talk to you in a little bit. Okay? Hey, folks, thanks for tuning in this afternoon. Callers, thank you for giving us calls. We appreciate that so much. And we will be back again live tomorrow to explore the world of mathematics. See you then.